Dear students, today in this lecture we will discuss about waste to energy recycling plant. We all know that in present scenario industrial waste are produced at a large scale and there is problem to dump this waste, as well as since industrial waste is hazardous to the environment also, so we need to do something to clear our environment from the toxics present in the industrial waste, as well as we need to reduce the volume of the waste because dumping yards are limited and we know in future we will not have many dumping yards to dump all the industrial and municipal waste. So a plant can be obtained which will fulfill 2-3 objectives, such as to reduce the volume of the waste, as well as to utilize the waste of after recycling, as well as if we can get some energy from this waste, it will be more beneficial. So here I am showing you a waste to energy recycling plant. Here electrical energy is generated and the waste material, first you can say I will show you here the bunker where the waste material is to be put for proper mixing. The waste material is put in this storage bunker and it is mixed by some methods, and after that the waste material will be put into the furnace where the combustion takes place, and there is a boiler where the steam is generated. But since this steam is contaminated with some toxic elements, so a system just as in red mark here one will be used before the steam is sent to the steam turbine, and that system is nitrogen oxide removal system, just as I am showing you here, number 1 in red mark. This nitrogen oxide removal system removes the toxic nitrogen oxide from the steam, and this steam is used in steam turbine which is coupled with an alternator to generate electrical energy, and this electrical energy is put onto the grid. So this is the process of generation of electrical engineering. Now the flue gases which are separated from the steam are now passed through 3-4 other systems, such as in red mark circle 2, 3, 4 and 5. These systems are used for different kind of purpose, just as the second system is the mercury and dioxin removal system, where mercury oxide and other toxic elements are removed. And after that, there is another system, that is system 3. When the flue gases pass through this, the acid gas present in the flue gases are removed. And then there is system 4, in which the particles present in the flue gases are removed. The removal may be because of many methods, many technologies can be used. Electrostatic precipitators may also be used here in system 4. And after that, a pollution control testing system is there, which checks whether the flue gases which will go into the atmosphere through the chimney are now polluted or it is environment friendly. And the flue gases will move into the atmosphere through a stack, and just as it is shown here, that is water vapor and clean flue gases will go into the atmosphere. And if we talk about the furnace, then we can say that after the combustion, a huge amount of the waste material is burnt and a very low volume of the ash will be obtained, and by ash conveyor belt it will be sent in another chamber and put into trolleys. Ash handling system may be there, and from there the ash will be disposed into the dumping yards or landfills, or it can be used for making bricks, etc. So in this way we can say that we achieve two objectives here. One is we can generate some amount of electrical energy, as well as we are able to reduce the volume of the waste material, so that the dumping yard required will be of less size. All these things are written here, and few technologies are used in this process, and these are specified here. One of them is incineration. Incineration is basically the combustion of organic materials so that energy can be recovered from the waste. And modern incinerators have a very high combustion efficiency. It's around 95 to 96% of the original waste, depending upon the composition and degree of recovery of the material. And the ash which is produced will be of very less amount. But incineration can emit very small particles, metals, acid gas, etc. also, and we have to filter the gases. We have to collect the heavy metals in different sections also. So for that I have discussed before in the diagram how we will collect these things. And There are some other technologies are also used in place of incineration, but here I will show you first the diagram of incineration plant. Here, as you can see, garbage bunker is here where the waste material is being put, and from here the waste material will be put again in the boiler, and a hot air will be provided from the bottom of the boiler through the furnace, and steam is generated which is used to produce the electrical energy, and the flue gases will be filtered through many sections before going into the atmosphere through the stack, and slags are obtained from the waste through the grate, and it is of very less volume and it can be dumped easily, or it can be utilized for landfills. But the efficiency of incinerators are very low, just around 14 to 28%. So we use cogeneration incinerators, because in cogeneration incinerators the steam is produced as well as the heat can be utilized for domestic heating, etc., and it can increase the efficiency of incinerators to around 80%. So all these things are written here, as you can see. Nowadays, a number of new and emerging technologies are used, because incinerators, some say that they are not good for the environment, as they may pollute the environment as well as the material which are obtained in the ash are also sometimes metallic and toxic, which may be harmful even for the land. So some other technologies such as gasification is used, which produces combustible gases and increase the efficiency of the plant. Also, thermal depolymerization may be used, which produce synthetic crude oil, which can further be refined, and efficiency can be increased by using this. Pyrolysis is also an option, in which tar or bio oils are produced, and these can be used at the energy systems to produce electrical energy as well as mechanical energy in some places. Also, plasma arc gasifiers are a new technology process which produce rich syngas gas, which includes hydrogen, carbon monoxide, and it can be used in fuel cells, or it can be used to generate electrical energy. So in this way we can say that the waste to energy system is a need of today, because we know a time will come when we have a very small amount of empty lands to dispose of the waste material. So it is required to reduce the waste material to a considerable amount, to around 1-2% of the actual waste material, so that a small amount of land will be used for that, as well as we can generate electrical energy from it in an alternate way, which is also good, because energy crisis will always be there. As the modernization will go on and on, the energy crisis will also increase in the world. So I can say that the waste to energy plants are a need of the today, need of the future, and we have to install more and more waste to energy plants. Also, I can say one more thing I can discuss here with you, that is waste recycle only plants. Here electrical energy is not generated, but the waste is segregated in the form of metallic waste, plastic waste, and other kind of waste. So you can see here the waste is first put into the pre-crushing chamber, and it is crushed here, and from here it is put into a size sorting and separation chamber, and here, if the diameter of the waste material are less than 60 mm, then it will go to another chamber, that is magnetic separation, and if it is more than 60 mm, then it will go to main crushing chamber again, where it is crushed again, so that its size is reduced below 60 mm. And in this magnetic separation chamber, the magnetic materials present in the waste is separated and put in different section, such as here in ferrous material section, while the remaining waste is again separated in a separator chamber, where plastics are separated, and the remaining waste is put into another chamber. In this way, the waste material is separated in the form of ferrous material, plastic, and non-recyclable materials. So this is a brief about the waste recycling plant. Thank you.